Hi everyone, it's Fada,
And Pengui.
and welcome to episode 2 of the MOSS C Programming Guide. Today we're going to go through a little more complicated program than we wrote last time. We're going to flash that program to the MOSS robot that we're going to build.
And to learn how to build this guy, go back to our MOSS Survival Guide series, episode 3. That link will be in the description if you're looking for that.
And we called him Mr. Derp.
Mr. Derp here.
Very simple. He sends his output of from number 3 and number 5 in the output of the brain
Into
the wheels, which is
So-
something important to know as you look at the program that we're going to show you in just a second.
Yes.
All right.
So let's get started.
Let's get started. Okay, let's take a look first at this program we have. It's a C program. It's called shortmaze.c. We're going to send our little robot into our maze straight, and then we're going to turn him left, and then we're going to go straight, and we're going to turn him right and go straight. So let's take a look at this program, shall we, Pengui?
Yes, we shall.
All right, so first thing we always do in these programs is the MOSS brain will call the setup function. So the setup function is doing nothing more when it sets this face value of the left wheel and the right wheel to 128. That just says, okay, start standing still. Because a wheel going backwards has a face value of 0, and a wheel going forward all the way has a face value of 256.
Yes.
So halfway in between is stopped.
128.
And then what's that last variable for?
This one's called first time through. So this sets a variable so that the program only runs once.
Oh, back in the loop there.
Yeah, the loop.
So you can see at the start of the loop, and by the way, the MOSS brain runs this loop over and over and over again. We check first time through if it equals 1. And you can see on the setup, which only happens once,
It equals 1.
it equals 1, but it only equals 1 the first time. Why is that? Because
later we say that first time through now equals 0.
oh, right. We set it to 0 so that it'll only happen once.
Yeah.
All right, so let's go look at the different sections of this. The first section is going to set the face value of the left and the right wheel to 255, and that again means all the way forward and fast as it can go.
Yes.
And so then that's going to go straight, and it says wait 2,000. That means 2,000 milliseconds.
Which is therefore 2 seconds.
2 seconds. So both wheels straight for 2 seconds. So it's going to go straight for 2 seconds. And then what's the next one?
And left turn, and so the left will turn, and you reverse the left wheel, for 280 seconds, and then you set the face value of the left wheel to 0.
Oh, guess what? We have a flaw.
We do?
We were messing with it. We said 300 seconds, and we didn't change our comment.
Oh, I'm sorry.
No, that was not your fault. We were messing with it together. So we updated our comment to actually match. Well, let's update this one here. Well, this is real-time programming. There we go. Keep the programs up to date. Okay, so that means we turned it left, and that left-hand turn took 300 milliseconds, or right about a third of a second to make it. And now that we've turned left in our maze, we want to go straight again. So we have to set the left wheel face back to going full speed
all the way,
ahead,
full speed.
and then we do it for
2 seconds.
2 seconds. Now we're at the next turn, and we have to turn right. So we're reversing the right wheel
for 270.
270 seconds.
Then we.
All right. So that makes it turn to the right.
Mm-hmm.
We're going to go straight for 2 seconds, which means we just set the right face value back to 255, which keeps it going straight. Then what do we do after that?
Then we stop so that both wheels are at 128, which is the wheel's midpoint where they're neither going forward or backward, so they are stopped.
Okay, so let's now actually compile and send the program down to the brain.
So we want to drag our program into the MOSS Flash program here.
So now it says it's compiling it, which means it's changing it from, oh, you can see real quick, we'll set that again. Sometimes it does that, it changes it, but Pengui will move it a little bit. And now as soon as that blue, there it goes, that's the first part. Now we're turning left, going straight, turning right, now we're going straight, and oh no! Hey, should we try it one more time?
Yeah.
Sometimes it goes a little different because of, sometimes the wheels grab differently, but let's try it one more time. So she's going to put it back, and I'm going to drag it on there one more time. And let's see what happens. It's probably going to do that little jerk backward thing again because as it loads,
There we go.
we haven't figured out why it does that yet. But
There we go.
while it's flashing or sending the data,
See
the
right
program.
here?
Oh, there it is.
Dash, dash.
And here we go. Now it's going straight. And it got off to the right-hand start. Now it's going to go over. Now! Okay, let's try it again.
Whoop.
Let's do this one more time. Let's see what happens. I'm going to...
It's okay.
All
Robot.
right.
Get
We
you to
would,
work.
we would like to get a way to make this thing so that we wouldn't have to reload it every time, but we haven't. We decided to do one step at a time. We'll get more sophisticated as our videos keep going on. So here we go. It's flashing it. And now here we go. Ooh, that looks like a better... Oh, this one's going to work.
Yes.
Yes!
Yes.
Success!
Aha.
All right, that is our short maze that had no input. We didn't take any sensor input. We just did a simple program to go straight, turn left, go straight, turn right, go straight. So yeah, you can kind of see how that works in kind of its most basic form. All right, nice job.
Yay.
Okay, thanks everybody for joining us for episode 2 of the MOSS C Programming Guide. Next time we will get a little deeper into programming a MOSS robot using C. Maybe we'll do a little bit of work with sensors and something different, something a little more advanced.
Yeah, so thanks for tuning in. Finger guns.
Finger guns.
Pew, pew. Pew, pew.